Hello students, welcome to chemistry class. Today we will discuss empirical formula and molecular formula. What is this empirical formula? So it is the simplest formula of the compound which expresses the relative number of atoms of different elements present in a molecule of a compound. That is, an empirical formula represents the simplest whole number ratio of atoms present in a molecule. So it is to be called as empirical formula. That is, it gives the simplest formula of a compound which expresses the relative number of atoms of different elements present in a molecule of a compound. For example, let us take acetylene. So acetylene has empirical formula that is CH. And let us take one more example, that is benzene. So this benzene has empirical formula also CH. And let us take glucose. So this glucose has an empirical formula that is CH2O. So what is this empirical formula? Just it indicates the simple whole number ratio of various atoms present in the compound. That is, the ratio of atoms in the acetylene is 1:1. That is 1 carbon and 1 hydrogen. And in the case of benzene also, so the ratio of atoms of carbon and hydrogen is 1:1. And in the case of glucose, the ratio of carbon, hydrogen and oxygen is 1:2:1. So it is the empirical formula of the glucose. And then what is meant by molecular formula? So this molecular formula shows the exact number of different types of atoms present in a molecule of a compound. So it gives the exact number of different types of atoms present in a molecule of a compound. That is, in the case of acetylene, so the molecular formula is C2H2. That is, it contains 2 carbon atoms and 2 hydrogen atoms. So this molecular formula represents the exact number of different atoms present in a molecule. That is, the ratio of carbon and hydrogen is 1:1. Same, but it gives the exact number of atoms. Right? So in the case of benzene, so the number of carbon atoms and hydrogen atoms are 6. That is, the molecular formula for benzene is C6H6. And in the case of glucose, so the molecular formula is C6H12 and it is O6. So this molecular formula gives the information about the exact number of atoms present in a molecule. But this empirical formula gives just a simplest whole number ratio of various atoms present in a compound. Just it gives the simplest whole number ratio of atoms. So this empirical formula is to be calculated from the percentage composition of the elements in a compound. It is to be calculated by using percentage composition of elements in the compound. And this molecular formula is determined after knowing the empirical formula mass and mass of the molecule. And this molecular formula may be either same as the empirical formula or a simple multiple of it. That is, molecular formula is always equal to the n into empirical formula. Let us see how to calculate the empirical formula and molecular formula by taking few examples. In that first one, a compound contains 4.07% hydrogen and 24.27% carbon and 71.65% chlorine, and its molar mass is 98.96 grams. So what is its empirical and molecular formula? So the organic compound contains three elements, so hydrogen, carbon and chlorine. Percentage of hydrogen is 4.07% and percentage of carbon is 24.27% and percentage of chlorine is 71.65%. That is, out of 100%, hydrogen percentage is 4.07 and carbon percentage is 24.27% and chlorine percentage is 71.65%, and the molar mass of that compound is 98.96 grams. So what is the empirical and molecular formula? Let us see how to calculate the empirical and molecular formula. First, let us take element, that is first element is hydrogen, and next element is carbon, and next element is chlorine, right? Cl. So the percentage of the elements, that is percentage mass of the elements, that is hydrogen is 4.07 and carbon is 24.27 and Cl is 71.65%. Next, let us take what is the atomic mass of the given elements, that is atomic mass. So hydrogen atomic mass is 1 and for carbon atomic mass is 12 and for chlorine its atomic mass is 35.5, right? So atomic mass of hydrogen is 1 and atomic mass of carbon is 12 and atomic mass of chlorine is 35.5. Next, calculate the molar ratio of elements, that is molar ratio is equal to percentage of the element divided by atomic mass. So percentage of element divided by atomic mass, that is molar ratio. So for hydrogen element, percentage of the element is 4.07 divided by atomic mass is 1, and for carbon percentage of the element is 24.27 divided by atomic mass is 12, and for chlorine percentage of element is 71.65 divided by atomic mass is 35.5. So on simplification, it gives hydrogen percentage 4.07 and for carbon, so 24.27 divided by 12, so on simplification it is 2.02, and for chlorine, that is 71.65 divided by 35.5, so it is 2.02. That is, molar ratio of element is equal to the percentage of the elements divided by atomic mass. Next, to calculate the simple molar ratio, that is simple molar ratio. So simple molar ratio is equal to the molar ratio of that element divided by minimum molar ratio. Minimum molar ratio. That is, molar ratio of the element, that is for hydrogen, is 4.07 divided by minimum molar ratio. So minimum molar ratio is 2.02, right? So it is 2.02. Like that, for carbon element, that is 2.02 divided by simple molar ratio 2.02 and 2.02 divided by 2.02, that is equal to, so 4.07 divided by 2.02, so it is 2.01. that value is nearly equal to 2, right? And 2.02 divided by 2.02, that is 1, and 2.02 divided by 2.02, it is also 1. So simple whole number ratio that is for hydrogen it is 2, and for carbon it is 1, and for chlorine it is 1. So this is a simple method to calculate the simple whole number ratio, right? So the empirical formula of the compound, empirical formula is equal, that is the ratio of carbon, hydrogen and Cl is equal to, so the ratio of carbon is 1, right? And the ratio of hydrogen, that is simple whole number ratio, is 2, and for Cl simple whole number ratio is 1. So the empirical formula of the compound is C1H2 and it is Cl1, or it is equal to CH2Cl. So it is to be called as empirical formula of the compound. And let us see how to calculate the molecular formula of the compound. So molecular formula is always equal to N into empirical formula. N into empirical formula. So what is meant by N? So N is nothing but integer. So how to calculate this integer? That is, N value is always equal to the molar mass or molecular mass divided by empirical formula mass. Empirical formula mass. So empirical formula mass of the compound, that is empirical formula mass is equal to carbon plus 2 into hydrogen plus atomic mass of Cl. So carbon atomic mass is 12 plus 2 into hydrogen atomic mass is 1 plus Cl atomic mass is 35.5. So on simplification it gives 49.5. So 49.5 is the empirical formula mass of the compound. So molar mass is already given in the problem, that is molar mass is 98.96 grams, right? So molar mass is 98.96 grams divided by empirical formula mass, that is 49.5. So on simplification it is 1.999, that is nearly equal to 2, that is N is equal to 2. So molecular formula of the compound is 2 into empirical formula, that is CH2Cl. So on multiplication it gives C2H, 2 2s are 4, and it is Cl2. So the molecular formula of the compound. Molecular formula of the compound is C2H4Cl2. So first we have to calculate what is the molar ratio of the element, then calculate simple molar ratio. So simple molar ratio is calculated by using the molar ratio divided by minimum molar ratio. So on simplification it gives the simple whole number ratio. So if it is not a simple whole number, then it is to be converted into simple whole numbers by multiplying a suitable integer. So here it is not necessary to multiply any integer with the number, because already the simple molar ratio is in the whole number ratio. So after calculating the simple whole number ratio, calculate the empirical formula mass and then calculate n value. So n value is always equal to molar mass divided by empirical formula mass. So molar mass 98.96 divided by empirical formula mass 49.5. So on simplification it gives 2. And this molecular formula mass is always equal to n into empirical formula, that is n is 2. 2 into empirical formula is CH2Cl, on multiplication so it gives C2H4Cl2. So in the examination they may ask any question for 5 marks. And next, second problem, that is a compound contains 6.7% hydrogen and 40% carbon and rest is oxygen. So we have to calculate what is the percentage of the oxygen. And here they have mentioned vapor density of the compound. So vapor density is 29.8. So we have to calculate what is the empirical formula and molecular formula. Let us see how to calculate the empirical formula and molecular formula. So first we have to calculate what is the percentage of the oxygen, and then we have to calculate what is the molecular mass of the compound by using this vapor density, and then we have to calculate what is the empirical formula and molecular formula. Let us solve step by step. That is, first one, calculate the percentage of the oxygen. So percentage of oxygen is equal to 100 minus percentage of carbon, that is 40, plus percentage of hydrogen, so it is 6.7, that is equal to 53.3%. Right? Let us see first one, that is element. So element is hydrogen, carbon and then oxygen, and atomic mass or percentage of element, that is hydrogen percentage is 6.7% and percentage of carbon is 40% and percentage of oxygen is 53.3%. And atomic mass of the elements, atomic mass. So for hydrogen atomic mass is 1, and for carbon atomic mass is 12, and for oxygen atomic mass is 16. Then calculate molar ratio. So molar ratio is equal to percentage of element divided by atomic mass. So percentage of the element for hydrogen is 6.7 divided by 1, and for carbon 40 divided by 12, and for oxygen 53.3 divided by 16. So on simplification, so it gives 6.7 divided by 1, that is 6.7, and for carbon that is 40 divided by 12, so it is 3.33, and for oxygen that is 53.3 divided by 16, so it is 3.33. And next, that is simple molar ratio. Simple molar ratio. So the simple molar ratio is always equal to the molar ratio divided by minimum molar ratio. Minimum molar ratio. That is, molar ratio is 6.7 and minimum molar ratio is 3.33. And for carbon it is 3.33 divided by minimum molar ratio 3.33. And for oxygen, so molar ratio is 3.33 divided by minimum molar ratio is 3.33. So on simplification, it gives that is simple molar ratio of hydrogen is 2, and for carbon is 1, and for oxygen is also 1. Therefore, the simple whole number ratio is, that is, for hydrogen it is 2, and for carbon it is 1, and for oxygen it is 1. That is, the empirical formula is equal to CH2O. That is, it contains 1 carbon and 1 oxygen and 2 hydrogen atoms. And let us calculate empirical formula mass. Empirical formula mass. So empirical formula mass is equal to the atomic mass of carbon plus 2 into atomic mass of hydrogen plus 1 into atomic mass of oxygen. That is 12 plus 2 into 1 plus 16. So on simplification, it gives 30 grams. So molecular mass, that is integer n is equal to molecular or molar mass divided by empirical formula mass. So molar mass is not given in the problem, right? So they have mentioned the vapor density of the compound. So how to calculate the molar mass by using vapor density? That is, molar mass is always equal to 2 into vapor density. 2 into vapor density. That is 2 into, so vapor density is 29.8. On simplification, it gives 59.6, and the unit is grams. So molar mass is 59.6 grams divided by empirical formula mass is 30 grams. That is equal to 59.6 divided by 30, that is equal to 2. So molecular formula is equal to 2 into empirical formula. That is 2 into empirical formula is CH2O. That is C2H4 and it is O2. So the molecular formula of the compound is C2H4O2. That is, in this problem we have learnt about how to calculate the molar mass if they have given vapor density of the compound. Let us see one more problem. That is, an organic compound contains carbon, hydrogen and oxygen. Give the percentage composition 5.085% hydrogen and 40.687% carbon, and the vapor density of the compound was found to be 59. So calculate its molecular formula. That is, first we have to calculate what is the percentage of the oxygen. That is, percentage of oxygen is equal to 100 minus percentage of the remaining elements. That is, carbon percentage is 40.687 plus hydrogen percentage is 5.085%. So on simplification, it gives 54.228%. So the elements are carbon, hydrogen and oxygen, and the percentage of the element is that is, carbon percentage is 40.687% and the percentage of hydrogen is 5.085% and the percentage of the oxygen is 54.228%, right? So atomic mass of the elements, that is, for carbon atomic mass is 12 and for hydrogen atomic mass is 1 and for oxygen atomic mass is 16. Next, to calculate molar ratio. So molar ratio is always equal to the percentage of element divided by atomic mass. So percentage of the element, that is 40.687 divided by atomic mass is 12 and percentage of hydrogen is 5.085 divided by 1 and for oxygen it is 54.228 divided by 16. So on simplification, so it gives, that is, for carbon it is 3.390 and for hydrogen is 5.085 and for oxygen that is 54.228 divided by 16, that is 3.389, right? And then the simplest molar ratio, simple molar ratio. So simple molar ratio is equal to molar ratio divided by minimum molar ratio. So molar ratio is 3.390 divided by simple molar ratio is, that is, minimum molar ratio is 3.389. And on simplification it gives 1, that is nearly equal to 1, and it is 5.085 divided by 3.389, that is equal to 1.5, and it is 3.389 divided by 3.389. So on simplification it is equal to 1, right? So the simple molar ratio for hydrogen is not a whole number. So we have to convert this 1.5 to simple whole numbers. by multiplying with a suitable integer. So that is the simple molar ratio of all the elements are to be multiplied with the 2. Simple whole number ratio. Whole number ratio, that is 1 into 2 is equal to 2, and 1.5 into 2, that is 3, and 1 into 2 is equal to 2. So if the digit involved is less than 5, then neglect the terms. If it is equal to 5, then it is to be converted into simple whole numbers by using a suitable integer. So the empirical formula of the compound, that is empirical formula is C is to hydrogen and oxygen ratio. So carbon is 12, hydrogen is 3, and oxygen is 2, right? Carbon is 2 and hydrogen is 3 and oxygen is 2. That is the empirical formula of the compound is C2H3 and it is O2. And then let us calculate empirical formula mass. Empirical formula mass, that is 2 into carbon plus 3 into hydrogen plus 2 into oxygen. That is for carbon, that is 2 into 12 plus 3 into 1 plus 2 into 16. So on simplification it gives 59 grams. And then we have to calculate molar mass, that is molar mass is always equal to 2 into vapor density, that is 2 into vapor density of the compound is 59, right? So it is 59, that is equal to 118. So N is equal to molar mass divided by empirical formula mass. So molar mass is 118 divided by empirical formula mass is 59, that is equal to 2, right? To calculate the molecular formula of the salt, molecular formula is always equal to N into empirical formula. So N is 2 into empirical formula is C2H3 and it is O2. So the molecular formula of the compound is C4 and H, that is 3 2s are 6, and oxygen 2 2s are 4, that is C4H6O4. That is the molecular formula of the compound. Molecular formula of the compound, right? That is C4H6O4. So these are the 3 varieties of problems in order to calculate the empirical formula and molecular formula of the compound.